Welcome back. I'm Dr. P. Pramod Kumar, Associate Professor in the Department of Mechanical Engineering, MLR Institute of Technology. In the video lecture series, Engineering Mechanics, today we will discuss friction on horizontal plane. The overview of today's lecture is problem solving on the topic friction on horizontal plane. Problem number 1. A wooden block weighing 30 newtons is placed on a horizontal plane. A horizontal force of 12 newtons is required to just move the block. Find the coefficient of friction and the angle of friction. This is the problem. The given diagram is a block of weight 30 newtons is resting on a horizontal plane and a force 12 newtons is acting horizontally. The 12 Newton force is just about to move the block. The body is still at rest under the action of 12 Newton force. Draw the free body diagram of the block. The block is resting on a horizontal plane. Weight of the block always acts vertically downwards and the reaction from the ground is perpendicular to the contact surface. Here the contact surface is horizontal. That's why the reaction from the contact surface is vertically upward and a force 12 newtons is acting horizontally. Now the body tend to move in the line of action of 12 Newton force or in the direction of 12 Newton force. The 12 Newton force is trying to move the body in its line of action. Now the tendency of the body is to move towards right side, therefore the friction will be in opposite direction to the motion of the body. The friction is opposite to the direction of motion. Now the body is under equilibrium. The body is under static equilibrium by the action of 4 forces. 1. Self weight acting vertically downwards and the normal reaction from the ground which is vertically upwards, and the applied force which is tending to move the body 12 newtons horizontally towards right side, and the friction which will be always opposite to the direction of motion of the body towards left side at the contact surface. Now the body is under static equilibrium under the action of these 4 forces. Apply static equilibrium equations to find the coefficient of friction and angle of friction. Apply static equilibrium equations. Sigma h equals 0. Sum of all horizontal components equal to 0. So towards right side I am assuming plus and towards right side assuming minus. So sigma h equal to 0. Sum of all horizontal forces is equal to 0. Here we have 2 horizontal forces. One is 12 newtons towards right side and F towards left side. So the equation is 12 minus F is equal to 0. From this equation we can get friction equal to 12 newtons. Friction is equal to 12 newtons. And another equation, sigma V equal to 0. Sum of all vertical forces equal to 0. Here we have 2 vertical forces. One is weight acting in the downward direction and normal reaction acting in upward direction vertically. Now assuming upward positive and downward negative, n minus 30 is equal to 0. From this equation we can get normal reaction n is equal to 30 newtons. So we got friction is equal to 12 newtons and normal reaction is equal to 30 newtons. Now we also know that mu, coefficient of friction is given by mu is equal to F by N, limiting friction divided by normal reaction. Substituting the values of friction and normal reaction into the equation, we will get the value of coefficient of friction. So mu is equal to 12 by 30, which is equal to 0.4. The quotient of friction is a unitless parameter. It is a ratio of friction to normal reaction. Both are forces. So, quotient of friction don't have any units. Now, find the angle of friction. The angle of friction phi is given by tan phi is equal to mu, where mu is quotient of friction. So, substituting the quotient of friction value, we can find the value of phi. So, phi is given by tan inverse mu, which is equal to 2.18. The angle of friction in this case is 21.8 degrees. 21.8 degrees. The quotient of friction is 0.4 and the angle of friction is 21.8 degrees. Let us solve another problem on friction. A body resting on a rough horizontal plane requires a pull of 82 newtons inclined at 30 degrees to the horizontal to just impede motion. It was found that a push of 100 newtons inclined at 30 degrees to the horizontal is needed to just move it. Determine the weight of the body and quotient of friction. In this problem, two different cases are given. One is a pull of 82 newtons at 30 degrees to the horizontal is required to just move the body or to impede the motion, and another case is a 100 Newton force inclined at 30 degrees to the horizontal. It is a push. In the first case, it is a pull. For the same body and the same contact surfaces, a pull of 82 newtons is required at 30 degrees to the horizontal to just move the body. And for the same body and for the same contact surfaces, a push of 100 newtons inclined at 30 degrees to the horizontal is needed to just move the body. By using these two cases, find the weight of the body and quotient of friction between the contacting surfaces. This is case 1, a pull of 82 newtons is required, and second case, a push of 100 newtons at 30 degrees to the horizontal is required to just move the body. Draw the free body diagram for the first case. The weight of the block always acts vertically downwards, and the normal reaction will be always perpendicular to the contact surface, and a pull of 82 newtons at 30 degrees to the horizontal is acting on the body. Due to the action of this 82 newtons, the direction of motion or the body tend to move towards right side. This is direction of motion. The friction will be always opposite to the contact surface. The friction will be always at the contact surface in opposite direction to the motion of the body. The motion of the body is towards right, therefore, the friction at the contact surface will be towards left. Now, by using this free body diagram, let us solve for the unknown values. The 82 Newton force which is acting at 30 degrees to the horizontal can be split into two components. One is horizontal component, that is 82 cos 30 and 82 sin 30. The 82 Newton's force which is trying to pull the body can be split into two components. 82 cos 30 is the horizontal component which is contributing to the motion of the body, and 82 sin 30 is contributing to the normal reaction in vertical direction. Now, apply static equilibrium equations. Sigma h is equal to 0. Sum of all horizontal forces equal to 0. Here we have only two horizontal forces. One is horizontal component of 82 newtons, that is 82 cos 30, and friction. only two forces are there in horizontal direction. Now assuming towards right it is plus and towards left it is minus. 82 cos 30 minus f is equal to 0. F is equal to 82 cos 30, which is equal to 71.01 newtons. Similarly, apply another static equilibrium equation, that is sigma v equal to 0. Sum of all vertical components is equal to 0. Here we have three vertical forces. Normal reaction is acting in vertically upward direction, and 82 sin 30 is also acting in upward direction vertically, and weight of the body is acting vertically downwards. The equation is N minus W. Assuming upward forces plus and downward forces minus, here normal reaction is acting in the upward direction, 82 sin 30 is also acting in upward direction, and only weight is acting in the downward direction. That's why only weight is having the sign minus, and N and 82 sin 30 both are acting in upward direction. Now from this equation, N is equal to W minus 42. 82 sin 30 is equal to 41. So W minus 41. We know that mu, the quotient of friction mu, is given by limiting friction by normal reaction. From this equation, the friction is given by mu into normal reaction. Now substitute the friction value and normal reaction value into this equation. The friction 71.01 is equal to mu into quotient of friction into normal reaction W minus 41. This is equation number 1. Now let us move on to the second case. Apply the free body diagram or draw the free body diagram for the second case. The block is resting on a horizontal plane. Weight always acts vertically downwards. Normal reaction will be always perpendicular to the contact surface. Here the contact surface is horizontal, so it is vertically upward, and a push of 100 newtons is acting at an angle of 30 degrees. Now in this case, the direction of motion of the body or the body may tend to move towards left. Therefore, the friction will be in opposite direction to the motion of the body. Friction will be towards right. Now apply static equilibrium equations for this case. The 100 Newton force can be split into two components, two mutually perpendicular components. 100 cos 30 towards left side is horizontal component, and 100 sin 30 downwards is its vertical component. Applying the static equilibrium equations, sigma h equals 0. Here we have two horizontal forces or horizontal components. One is 100 cos 30 and friction. 100 cos 30 minus f is equal to 0. F is equal to 86.66 newtons friction, and sigma v equal to 0. Sum of all vertical components or sum of all vertical forces equal to 0. Now here we have three vertical forces. W and 100 sin 30 are acting in the downward direction vertically, and normal reaction alone acting in upward direction. N minus W minus 100 sin 30 is equal to 0. N is equal to W plus 50. Already we know that mu, quotient of friction, is given by friction by normal reaction, and friction is given by mu into normal reaction. Now substitute the value of friction and normal reaction into the equation. 86.60 is equal to mu into W plus 50. This is equation number 2. Now equation number 2 minus 1. Subtract the equation number 1 from 2. This is equation number 2. minus equation number 1. Do subtraction, we will get 15.33 is equal to 91 mu. From this we can calculate mu value. Mu is equal to 15.53 minus 91. The value of mu, coefficient of friction, is given by 0.17. Now substitute mu value in any one of the equations. Let us say substitute in equation number 1. 71.01 is equal to mu into W. Mu is 0.17 W minus 41 mu. So 41 into 0.17. By solving this equation, we can calculate W. So the W, the weight of the block in this problem, is given as 458.7 newtons. Like this, we can solve problems on friction when the body is resting on horizontal plane. Thank you.